In this video, I introduce learning latent dynamics for planning from pixels. Planning has been very successful for control tasks with knowing environment dynamics. To leverage planning in unknown environments, the agent needs to learn the dynamics from interactions with the real world. Deep planning network is a model-based agent that learns the environment dynamics from images and chooses actions through faster online planning in latent space. Partially observable Markov decision process is defined as the four stochastic dynamics, namely transition function, observation function, real-world function, and policy, as shown here. This is observation, this is real-world, this is policy, and this is transition. The goal is to implement a policy P to maximize the expected sum of rewards, where T is the length of a trajectory and the expectation is over the distributions of environment and the policy. To solve unknown environment via planning, planning network models the environment dynamics from experience. Planning network learns a transition model P, observation model, real-world model from previously experienced episodes. The observation model provides a rich training signal, but is not used for planning. An encoder Q is used to infer approximate belief over the recurrent hidden states from the history using filtering. Given these components, planning network implements the policy P as a planning algorithm to search for the best sequence of future actions, as shown here. This is latent planning in latent space, and this variational autoencoder. Since the agent may not initially visit all parts of the environment, planning network iteratively collects new appearance and refines the dynamics model. Starting from a small amount of C episodes and random actions, a planning network trains the model and adds one additional episode to the data every C update steps. Planning net iteratively collects the data using planning and training the dynamics model on the gathered data. Drawing sequence chunks uniformly at random from the dataset with the image observations, continuous actions, scalar rewards. The encoder Q approximates the state posterior from past observations and actions, where Q is a diagonal Gaussian with a mean and variance parameterized by convolutional neural network followed by a feed-forward neural network. The loss for predicting observations is defined as here. This equation 3 showing the here, which contains two items. The first is a reconstruction. Second is a regularizer. This is a state posterior. This is a latent transition prior. This is a variational bound. Here is the pseudocode of a deep planning network, which consists of two modules. One is model fitting, one is data collection. Latent planning applies the cross-entropy method to search for the best action sequence in latent space under the model. Planning network initialize time-dependent diagonal Gaussian belief over the optimal action sequences A from T to T plus H, where T is the current time step of the agent and H is the length of planning horizon. Starting from a zero mean and unit variance, planning network repeatedly samples G candidate action sequences, evaluates them and the model, and refits the belief to the top key action sequences. After I iterations, the planner returns the mean mu t of belief for the current time step. After receiving next observation, the belief over action sequences starts from zero mean and unit variance again to avoid local optima. Here is the pseudocode of latent planning with the cross-entropy method, which consists of two modules. One is evaluating G action sequences from the current belief. One is refit the belief to the key best action sequence. For more details, please check with these references. Thank you. Bye.